How are we doing?
How are you?
I'm doing all right, thanks. Here 4 weeks. One thing I did want to mention, if you're interested in the dual degree program that we have with Washington University in St. Louis, a representative from there will be here next Tuesday at noon in Lady Tabor 115. If you're not interested, you can ignore what I'm saying. But if you're interested in it at all, or think you might perhaps be interested in engineering at some point, come check it out. They can talk about their program. Even if you have a class that goes till 12:15, they'll be there till at least 1. So come by late if you need to. But anyway, I just want to make sure I announce that because getting information from places if you're interested in it is always important. So, all right. Anyway, any questions about anything at all? As we continue our discussion of law signs. Yes.
One, I think this inverse thing that we're doing, a little bit more practice. I'm getting used to it. I got used to it a little bit with the homework.
Mm-hmm.
But I'm still having trouble with the problem where you got sign, like the inverse on the inside, or it's the inverse outside.
Okay.
I don't think I can do those homework.
Okay. So remember that with the best way I can tell you to do those particular ones is take it a step at a time. Don't try to do it all at once. Okay. So if you've got like inverse sine of 5 pi over 6. Okay. Ignore this. Figure out what sine of 5 pi over 6 is first. So since it's a pi over 6 angle, the sine is going to be what? One half, and then 5 pi over 6 is in quadrant 2, and so it'll still be positive, so it'll be positive a half, right? So simplify the inside. Now do your inverse sine. So remember, inverse sine now gives you an angle in quadrant 1 or 4, right? It's always between negative pi over 2 and pi over 2, so it's in quadrant 1 or it's in quadrant 4. That one has to be in quadrant 1 because it's positive. So you want the angle in quadrant 1 that gives you a half. Just told me a second ago it was pi over 6, right? So this will simplify to pi over 6. So in these, I would do them a step at a time. I would ignore the inverse on the outside, do the computation, and then just treat this like it's a new problem. That's how I would do that. The other way around actually is a little bit easier. At least I think it's a little bit easier. If this number is between negative 1 and 1, then it's just that number. If it's not between negative 1 and 1, say something like that, I can't put negative 4 into the inverse sign, so this is just undefined. So I think these are a little bit easier in this direction. This one I would just encourage you to work inside out. Just do it a step at a time. Other questions at all? All right, well, let's finish off this problem we started last time. And then do a few more of these. Probably do some application problems as well today. So we drew the triangle last time. They told us that the length of side A is 25, length of side B is 26, angle at A, that alpha is 70. So notice that we're in that 2 sides and an angle, but it's not included, right? So that's going to be one of those, that's what we typically refer to as the ambiguous case. Okay? But remember, side angle, or like I said better, angle side is not a congruence theorem. Okay? So in this case, we have to be careful. There might be no triangle, there might be one triangle, there might be 2 triangles. Can't have more than two. But it's either 0, 1, or 2. So we have to go determine which one it is. Okay? So we set it up, though, the same way we did it last time, or in previous problems. We did sine of 70 over 25 is sine of beta over 26. That's perfect. That's exactly what we should do. We went through and got a 77.76 degree angle roughly for the beta, right? However, this may not be the only possibility. Because remember, again, if I do sine of an angle or the sine of its supplement, I get the same value, right? We can think about it in terms of reference triangles. Whoa, that was weird. It jumped on me. If I have a reference triangle over here, and this is my theta, I could also have the exact same reference triangle over here in quadrant 2, where this is theta, and so then this angle would be the 180 minus theta, right? Those two triangles have, or excuse me, those two values, one more time, those two angles have the exact same sign, SIGN, right? Or not SIGN, SIGN. They have the exact same sine value, right? The sine of each of those angles is the same because my opposite side is positive in both cases, right? And certainly I can have an obtuse angle in a triangle, okay? So I need to check would an obtuse angle also work, okay? So that's why we did that checking last time. And I immediately checked, right? We didn't solve the rest of the triangle to start with. Immediately checked to see if there's a second triangle in this situation. Okay, so what did we do? Well, we calculated the supplement, 180 minus that angle, got 102.24. The other angle in the triangle that we were given was 70. Added that together, it was less than 180. That's okay. So there is a second triangle. Okay, so now when you have a problem like this, you actually have two triangles to solve instead of one. Okay, so let's collect our information. So far, we had an alpha was 70 degrees. We had A is 25. We had B is 26. In this one, our beta was calculated to be 77.76, right? And we still need our angle at C and our length of C, right? We still need those two values for that one. In our second triangle, we still have the same A, we still have the same alpha, we still have the same B, but our beta changes to 102.24. Right? Does that make sense? Okay. Now, in both cases, we should be able to figure out gamma pretty easily, right? In either case, how do you figure out your gamma? If you know alpha and beta, how do you figure out your gamma? Add them up and subtract it from 180, right? Add these two together. What do we get? 147.76. So you'll get, what, 132 point... not 132. I'm adding wrong. Sorry, 32.24. Is that right? That's what calculators are for, right? 147. Yeah, that seems right. You'll have a calculator to do that, yes. Okay. I would also encourage you that even though when we've been writing these down, we're rounding them to 2 decimal places. Since we'll be using this gamma to help us figure out the C, make sure you keep your digits in your calculator. Make use of your previous answer button function. Okay. Over here, we added these two together and got 172.24 already. If we subtract that from 180, you should get, what, 7.76? Once we have two angles, finding the third one's pretty straightforward, right? I hope. Now to figure out C, in either case, to figure out the C value, we need to set up our ratio with our law of sines. I'm already using a rounded angle even if I keep my digits in my calculator, I'm using a rounded angle. This looks like I wrote degrees Celsius, doesn't it? I'm using a rounded angle here. I probably want to set it up with A rather than B because there's a rounded angle here too, right? I would go off the information that you're given, since you wouldn't be rounding that, rather than using a rounded number and another rounded number to round another number. The more you round, the more you can get it rounding errors. Okay. So anytime you're able to base off of numbers that are given, do that. Okay. All right, so using that principle, if I do sine of 70 over 25, and I want to figure out what C is, what ratio should I set that equal to? Good. And it's going to be the exact same in the other one, except instead of 32.24, we'll use 7.76. Literally the same equation, just plop out one number for the other. And then again, this is what a calculator is for.
for the first one.
Cool. Okay. Thank you for it. Anybody else get those? See other people typing. Yep. Cool. Good. All right. The process okay?
Yeah.
I mean, the process in all of these are exactly the same. The only weird thing comes up is if you use the law of sines to find an angle first, check if there's a second triangle. Okay? And that literally is the only weird case of everything that we're going to do. The only weird case pops up is if you solve for an angle using the law of sines as your first step. Okay? That's the only weird case that pops up. Okay? I'm lying a little bit. There is another thing, but we just have to be careful in the other thing, and then we don't have to worry about it. It comes up with the law of cosines, which we'll talk about next week. All right. Let's see if we can do the next one. This one's set up similarly. We're given A, B, and beta in this case. Before I do anything else with this problem, let me ask you a question first. What do you think you need to solve for first in this problem, the way it's set up? Alpha, right? I'm given beta and B, and I have the A but not the alpha, and I don't have anything for C or gamma, right? That's not going to work. Okay, so I need to solve for alpha first, right? Okay, looking at the setup, is alpha going to be bigger than beta or smaller?
Bigger.
It's going to be bigger, isn't it? How do you know it's bigger?
The side's bigger.
The side's bigger, yeah. The side across from A is bigger than the side across from B, right? So my A should be bigger. Okay? And this actually is going to be a little bit of a hint into what might happen in this case. All right, so tell me what ratio we're going to set up to figure out the alpha to start with. Yeah. Cool. Good. Exactly. Oops. I wrote my 7 so early. Sine alpha over 7. Perfect. That's exactly right. That's what the law of sine says, right? So we'll need to multiply both sides by 7 and then do the inverse sine. What do you get when you do that computation? When you do 7 sine of 73 over 5? Before you take the inverse sine. A lot of times I write it all in the same step. But what do you get when you take 7 times sine of 73 over 5? 1.34? There's a reason why I didn't tell you to just do it inverse sine of that. Sine of something equals something bigger than 1. But if I plug in something into the sine function, what's it always in between? Negative 1 and 1 and 1. So is this going to have any solutions? No. And if you put inverse sine of that number in your calculator, you should get an error. Okay? It'll pop up. If you typed it all in at once, you'd get an error. So in this case, this is impossible. So how many triangles do you think we have? 0, yeah. So there's no triangle. So again, I got the sine of something equals something bigger than 1. And this is why I went through that discussion, by the way. I have this 73-degree angle. I know this angle has to be bigger, right? But I can't have two huge angles in a triangle and then without the level being really, really tiny. So I was thinking in this case I probably was going to get something that wasn't going to work. So this is an example of where we have no triangle. Okay. Let's do this next one. So this one, given B is 4, given, C is 5, gamma is 81 degrees. What do you think we should solve for first, looking at the way it's set up? Beta, right? I've got this one, that's nice. I've got both pieces that I would need for my ratio. A is unhelpful because I don't have either piece in my ratio, so I better use the beta first. So again, if you're going to use the law of sines to solve for an angle first, which is what this is telling me to do, I need to check to see if there's a second triangle. Okay? Do that every single time. All right? Should your beta be smaller or bigger than the gamma? Smaller, because it's across from a smaller side. So this one's probably going to be okay. We're probably not going to get no triangle here. Okay. So what is your ratio that you'll set up here? Hello. How are you? Good. What's the ratio we'll set up? Good. Fantastic. Yep. Then again, we'll solve for beta. This one I'll go, I'm confident that it's going to work out okay this time. Your beta will be inverse sine of 4 times sine of 81 over 5. You don't have to write it all in one big step if you don't want to. Just doing it to save a little bit of writing space for me. But I would multiply both sides by 4 and then do the inverse sine, right? I'm confident, one of the reasons why I was confident this is okay, sine of 81 degrees will be less than 1, and 4/5 is less than 1. And if I multiply two numbers together that are less than 1, I get something that's less than 1. So I'm not going to have any issues. What do you get when you do that calculation? $52.20. Is that what you said? Okay. Yes.
So before we
If it's less than 1, then you're okay. Yep. If it's bigger than 1, then there's no triangle. Yeah. So if you want to do that part first and see if you got a triangle or not. That's great. Yep, that's exactly right. Good job. Yep. Yes.
So in some cases, yeah, the question before, the saw is longer. You know what I mean?
Mhm.
I guess would that, I guess, give a hint to whether or not like the song would be equal to like something over one.
It's an indication it might happen. It's not a guarantee, but it's an indication that it might happen. Yeah. Because notice that this, when you do the 7/5, you get a number that's definitely bigger than 1. If this is close to 90, you're probably not going to get a triangle. If this is small enough, then it'll be okay. But if I give you something that's going to be a fraction that's bigger than 1, and that angle is close to 90, it's probably not going to be probably not going to be a triangle there. Yeah, 73 was close enough. But if I would have put something in like, let's see, that's 1.4, so something less than 45 degrees would have been okay. But I would have had been less than 40. I think anything around 45 degrees or bigger is probably not going to work. The reason why I know around 45 degrees, 7/5 is 1.4. Root 2 is about 1.4. So 1 over root 2 is assigned to 45 degrees. They roughly cancel each other out to give you 1. So that's why I know around 45 degrees would be okay. Less than 45 would be okay. Greater than 45, not okay. I don't expect you to do that kind of estimation on the fly. All right. Anyway, this is again an example. We found the angle first. So we should check to see if there's a second triangle. How do we check? What do we do? Good. So check for second triangle. We do 180 minus 52.2, which is what? 128.8. And then we add the 81 that we're given, right? That's 209.8. So is that going to work? No. So this is greater than 180. So no second triangle. If you take, so again, the steps are take the supplement, is what we did. The supplement of the angle we just found, right? Supplement of that angle. Subtract it from 180. Add it to the angle we're given. If it's less than 180, there's 2 triangles, so you need to find both the information. If it's greater than 180, there's no second triangle. You just have to go back to the original and you're done. Okay. All right. But again, I would always check for that second triangle before you do anything else, go any further with the problem. Okay. And again, the only time you have to worry about checking for a second triangle is if you're finding the angle first using the law of sines. There will be problems in the next section where we'll find the angle first using the law of cosines. You don't have to check for a second triangle there. Okay? You only have to do it in finding the angle first using the law of sines. It's the only time you have to worry about it. Okay? All right, now we've found what? We know B is not 5, B is 4. We know C, we know gamma, we found beta. We need to know A and alpha. Which one should we find first? Alpha. That one's the easier one, right? Alpha, you'll do 180 minus the sum of the other 2. I should say approximately equal to. What did you get for that one? 46.8, is that what you said? Okay. Again, we're rounding here. Keep your digits in your calculator to keep your rounding errors to a minimum. I don't care if you write them all out on your paper, but keep them in your calculator. All right. Then what ratio are we going to set up to figure out your A?
Sine 81/5 equals sine 46.8 over
Over 5. And the other one, you said it correctly. Good. Again, I would go back to the 81 and the 5 versus using the 52 and the 4 because the 52 is a rounded number. And if you use a rounded number to find another rounded number, you're going to compound rounding errors. So we'll go back to the ones that you're given every time that you can. I mean, I'm already having to use one rounded number here. I don't want to use another one there to round this one. Just give them a rounding error. Solve for A. Bounce off the chalk tray. Solve for A. 51 sine of 46.8. Sine of 81. What did you get approximately for that one?
3.69.
3.69? Is that what you said? Okay. It's okay? What questions do you have? Work on the next one for a minute or two. Actually, let's go ahead and work on the next page for a minute or two, more than a minute or two. And we'll chat about it when you're done. So work on the next 3. Then we'll chat. Holler at me if you got questions. But let's just practice and make sure we're all on the same page. How's that sound? Sound good? Good? One nice thing about this class is the pace is slower.
If I did all that correct, I think there was that triangle. Because that's given to it, and that's what I found. So it's going to be 180 times 30.89 plus the 29.
Yep.
You need like 178.
Yeah.
And that gives you second triangle.
Yeah.
What were we doing?
Okay, so you find your third angle by subtracting that from 180. So it'd be a tiny triangle, and then, or just the tiny angle.
Would the sides be the same?
The sides for A and C would be, you'll have to recalculate B.
Okay.
Yeah.
So that's the only difference?
That's the only difference, yeah. Yeah, so you'll get a new angle, you'll get a new side length. Yep.
So remind me of angle. This how I'm the first one. What I just do 180 minus the angle I found is 30.89 and add this angle that I was given.
Yep.
Okay.
Yep.
Okay.
And that's right. And that's yeah, so that's the 180. Yep. Yep. That's right. Yep. A is 17. We have C is 18. We have alpha is 29. We calculated gamma to be 30.89. We need to figure out B and beta. What did you get for those values?
What, 30.4 for B?
Say it again, 30.4? Okay. And for beta?
120.11.
120.11. Is that what everybody got? Awesome. Triangle 2. The values for A and C did not change. Value for alpha did not change. Gamma's value now is 149.11. What are B and beta?
For triangle 2?
Yeah.
30.27.
What was 30.2?
Oh, 30.27.
3.2. I thought you said 30. I'm like, wait a minute. And then the angle was
1.89.
1.89. A tiny little angle for the second triangle. So what everybody got for that one? Or do you have questions about that one? Don't care about that one? Yes, Eddie.
Since we, like, the first thing we saw for was gamma,
Mm-hmm.
so then, like, if there is a second triangle, like, it won't always be like gamma, but like whatever you saw for first, for the second triangle, it'll always be that number you get minus 180.
Yes.
Okay.
Yep. It'll always be that number you get minus 180. That's right. Yeah, if there is a second triangle, then the supplement is the angle that you found.
Okay.
Yep, that's exactly right. You got it. Sorry if I didn't make that clear earlier. But yeah, that's exactly right. Yep. Okay. We okay with that first one? I won't have time to get through all three, but I do want to mention something about the second one. Just looking at the way the problem is set up, do I have to worry about a second triangle? No. Beta is obtuse in this case, right? Think about when we get our second triangle, we have an acute angle that works and an obtuse angle that works. But you can't have two obtuse angles in the same triangle, right? So since this says beta is 95 degrees, I don't have to worry about a second triangle. Okay? Even though I'm going to find an angle first, there is no second triangle. Beta is too big. You don't have to check. If you check, you'll find out there isn't one, right? But you don't even need to bother checking because my beta is obtuse. Okay. So I'll just write down given angle is greater than 90 degrees. So there is no second triangle. I don't even need to bother checking. Okay. Again, if you don't want to think about it and you do go ahead and check for a second triangle, you will find there isn't one. The two obtuse angles will add up to more than 180. It'll be too big. All right. What did you get for the alpha in this case? Yep. Okay. So you've got your A is 5, your B is 24. Still need to find C. Your alpha was 11.98. Your beta was given to be 95. And then you'll find our C and our gamma the same way. What'd you get for those values?
C 23.04
Okay.
and 73.02.
Cool. And again, there's only going to be the one triangle in this case. Is this okay? I'm going to go ahead and hand out the sheet with application problems. I want you to try a few of them for, there's only 4 of them. Try a few of them for next time, just for practice. We'll go through these, but just see if you can convert what we've been doing here with law of signs into applications. That's kind of the whole point of this. You're welcome. You're welcome. Well, like I said, we'll chat about these next time. Like I said, see if you can practice them, see if you got the idea that you can convert it over. All right. Otherwise, we will see you on Friday. It is Wednesday, right? I lose track of the days of the week pretty quickly. We'll see you on Friday. Have a good one, everybody. I had a student a few years ago that would every time we'd end up class, go, "Good job today, everybody." So I like that tradition.